All right, today we're going to tackle something that's really at the heart of artificial intelligence. And it's not about bigger data or faster processors, it's about something way more human, meaning. So let's just dive right in. For decades, this one simple question has been the puzzle for AI researchers. It's pretty much the holy grail, right? How in the world do you take all the rich, kind of messy, but beautiful complexity of how we humans think and talk, and then translate that into something a machine can actually work with?
And look, don't get me wrong, this is way more than just some academic thought experiment. Cracking this problem, that's the key. That's what's going to unlock the next generation of truly intelligent systems. We're talking about AI that can reason, that can communicate, and help us in ways we've pretty much only seen in sci-fi movies.
So what's the big deal? Well, at its core, the problem is pretty simple to state, but incredibly hard to solve. For a computer, a word like love or justice is just data. It's empty. The real challenge is building that huge, invisible web of context and relationships that gives those words meaning inside the machine's mind. And that's where a main topic for today comes in. There's this really powerful and, frankly, ambitious approach designed to do exactly that. It's a system called MultiNets, and you could think of it as a kind of universal translator, but for meaning itself. So what is MultiNets? The full name is a bit of a mouthful. Multi-layered extended semantic networks, but the idea behind it is super important. This isn't just another program. It's a foundational framework. Think of it like a whole new language designed from the ground up to map the concepts behind our words into a structure that an AI can actually navigate and understand.
And the mission here, it's crystal clear. It really breaks down into three big goals. First, you've got to represent knowledge in all its glorious complexity. Second, you have to map out how we humans actually connect ideas. And then third, you use that map to power smarter, more capable AI. See, the framework itself isn't really the end goal. It's the engine that's going to drive that next generation of AI.
Okay, so how does it actually work? Well, MultiNets is built on a couple of core principles that really give it a unique edge. Let's break those down.
First and foremost, its ambition is huge. We're talking universality. The goal here wasn't just to build another tool for computer scientists. No, the idea was to create a common language that could bring together all these different fields, from cognitive psychology to philosophy, all focused on that same shared challenge. How do we represent meaning?
Yeah, you can really think of it like a Rosetta Stone for meaning. It allows all these different fields, and even different AI systems, to speak the same fundamental language of concepts. It's all about breaking down those walls between disciplines and even between machines. Okay, the second big idea here is what's called linguistic independence. This is so cool. MultiNets basically separates the core idea from the specific word you use to say it. So whether you say the cat sat on the mat in English or el gato se sentó en la alfombra in Spanish, the underlying structure, the representation of a cat, an act of sitting, and a mat, that stays exactly the same. And this is absolutely massive for creating AI that can work globally. So a powerful idea like this doesn't just pop out of nowhere, right? Where did it come from? Well, turns out MultiNets is this fascinating blend of two very, very different ways of thinking. Okay, so on one side, you've got the world of formal logic. Think of this as like the systems engineering backbone. It provides the strict rules, the mathematical precision you need for predictable, logical reasoning. But then, on the other side, you have cognitive science. This is more like the system's understanding of human nature. It pulls from ideas about how meaning can be fluid, how it depends on context, how it's kind of messy, just like real life. And the real magic, the secret sauce, is when you bring these two worlds together. MultiNets takes that super rigorous, predictable structure from formal logic and smashes it together with the nuanced, human-centered understanding from cognitive science. It's literally the best of both worlds. And that logical foundation, that set of core, unbreakable rules, is absolutely critical. It means an AI using MultiNets isn't just storing facts like some giant dictionary. It actually has inferential power. It can deduce new information from what it already knows. And that is a cornerstone of what we'd call real intelligence. Okay, so this is all super fascinating theory, right? But what does it actually mean in the real world? Why should we care about this complex system? Let's talk about some of the practical stuff. Well, MultiNets has already been put to work in some seriously cool ways. For instance, it's been used as a universal translator, not between human languages, but between different computer systems that couldn't otherwise talk to each other. It's also acted as a smart interface, letting you ask a super complex database questions in just plain normal English.
And it's even been used to power educational tools, like an automatic tutor that can actually understand a student's questions. So, if there's one thing to take away from all this, it's this. Frameworks like MultiNets are what's pushing AI beyond just simple pattern matching. They're a huge step towards creating machines that don't just spit back information, but can start to genuinely grasp the actual meaning behind our words. And all of this leaves us with one final and pretty deep question to think about. We're building these incredible systems that can map our meaning with near-perfect precision. But does a perfect representation of meaning equal genuine understanding? That's a question that takes us right out of computer science and into the heart of philosophy. And it's something we're all going to be grappling with as these amazing systems keep getting better and better.